Okay, we have to find the general solution of this d2y over dx square plus 5 dy by dx plus 6y that is equal to minus 2x squared. So now this is the inhomogeneous case over here, the differential equations, the second order differential equations, which are also inhomogeneous. And here instead of 0 you have minus 2x squared. So we'll be finding that auxiliary equation from the left hand side first. Okay, so we'll say, okay, you have to show this working, that let's say y is equal to a e raised to power lambda x. This is for the left hand side. So you have dy by dx is a lambda e raised to power lambda x. Then you have d2y by dx square, that is a lambda square e raised to power lambda x. Now substituting both of these derivatives into the left hand side, okay, uh, we have this, let me change the color. This is a lambda square e raised to power lambda x plus 5a lambda e raised to power lambda x plus 6a e raised to power lambda x, that is equal to 0. So I am going to take a e raised to power lambda x common from here. I have lambda square plus 5 lambda plus 6, that is equal to 0. So we have lambda plus 2 into lambda plus 3 equal to 0. So this is lambda equal to minus 2 and lambda is equal to minus 3. So my complementary function over here is going to be y is equal to a e raised to power minus 2x plus b e raised to power minus 3x. So since for these inhomogeneous second order differential equations, we have the rule that the general solution is the complementary function plus the particular integral. Now for the this particular integral is for the right hand side. So you will suppose that y is equal to alpha x plus beta. So this will give
Minus
us.
2x squared.
Hmm? No, no, we'll not be keeping.
Minus.
No, 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 not at all. Like this is just, see, this is linear. You have to see that this is linear, okay? So this is your dy by dx is alpha, and your d2y by dx square is going to be 0, okay? Now, putting this y, this first derivative, the second derivative into all of this equation so that we can determine the particular integral, okay? So I'll be making some space here for this. Okay, so अच्छा, so this will be
सर क्वेश्चन में -2x² था.
oh, thank you. Thank you. I was just ignoring you. I thought you were saying that I should put minus 2x over. Oh, thank you, Isha. So I think this would be alpha. Let me correct this. This is alpha x square plus beta x plus gamma. So my dy by dx has to be um, 2 alpha x plus beta, and my second derivative would just be 2 alpha. Okay. Now we have to put all this information into this equation here. So we have here um, 2 alpha plus 10 alpha x plus 5 beta plus 6 alpha x square plus 6 beta x plus 6 gamma, and that is equal to minus 2x square. Okay. Now by comparing the coefficients of x square, through comparing the coefficients of x square, we have this 6 alpha is equal to minus 2. So 6 alpha is equal to minus 2. So my alpha is minus 1 over 3. Next, let's compare the coefficients of x. Okay, so I have 10 alpha here. Then I have 6 beta here, and that is equal to 0. So the 6 beta is going to be 10 over 3. So this beta is going to be 2 threes are 2. This is going to be 5 over 9. Okay. Next, we are going to compare the constants. Okay. So let's comparing the by comparing the constants. So we have 2 alpha plus 5 beta and then plus 6 gamma, and that is equal to 0. So this is minus 2 by 3 plus 25 over 9 plus 6 gamma, that is equal to 0. So 6 gamma is going to be, this is 9 is the LCM, so 3 twos are 3 threes are minus 6 is 19 over 9, है ना? So it's minus 19 over 9. So your gamma is going to be minus 19 over 54. Okay, now we are going to combine, put this in this, the for the general solution, we have, this is our complementary function, okay? And now we have got the values of alpha, beta, and gamma. So this y is going to be equal to, let me use a better color here. Does it work well? Yeah, this y is going to be equal to AE, can you please quickly check the answer? Plus BE raised to power minus 3x. And then you have minus 1 over 3x squared plus 5 over 9x, and then we have minus 19 over 54. That is the general solution to this inhomogeneous second order differential equation. Yes, Zenia, did you see, check the answer? Or Isha? Hmm.
सर यही आंसर है.
Chalo, shukran. Okay. Uh, Now, the second question. Second question. We have, in this second question, we have d2r over dt square minus 4r, that is going to be 3 cos t. Okay, for this left hand side, you will say let r is equal to a e raised to power lambda t. Okay, so dr by dt is a lambda e raised to power lambda t. Then you have d2r by dt square, that is a lambda square e raised to lambda t. So we have then we have this putting into this for this auxiliary equation for the complementary function. So this is for the complementary function. The left hand side would be written as a lambda square e raised to power lambda t minus 4a e raised to power lambda t, that is equal to 0. So you have a e raised to power lambda t common here. You have lambda squared minus 4 equal to 0. So lambda square minus 4 equal to 0. So lambda is going to be plus minus 2. So your complementary function is y is equal to a e raised to power minus 2t plus b e raised to power 2t. Next, for the particular integral, I'll be putting this r is equal to alpha cos t plus beta sine t. So we have dr by dt is minus alpha sine t plus beta cos t. And then the second derivative, d2r over dt square is going to be minus alpha sine t minus beta. Sorry, this is, I have to cancel this. This is minus alpha cos t minus beta sine t. Okay, now look, let's put all of them into this equation here. So we have minus alpha cos t minus beta sine t minus 4 alpha cos t minus 4b sine t, that is equal to 3 cos t. Now we can easily compare the coefficients of cos t and sin t. So when I compare the coefficients of cos t, so I should have minus alpha, like this is also, oh yeah, this is minus 5 alpha, and that is equal to 3. Minus 5 alpha, that is equal to 3. So your alpha is minus 3 over 5. Okay, and beta would be obviously 0 because there is no term in sine over here. Therefore, we have now this general solution is going to be complementary function plus the particular integral. So this r is equal to a e raised to power minus 2t plus b e raised to power 2t and minus 3 over 5 cos t. Okay, so that is a general solution. Now we have to find the particular solution as well. Okay, so I'll be covering all of this because I don't need this area here. So I can cover this much. Yes. Okay. Now it says there was. ठीक है. अच्छा. So we have been given r is equal to 1, dr over dt equal to 1, and t equal to 0. Let's put this t equal to 0 and r equal to 1 into this equation. So I have 1 is equal to a plus b minus 3 over 5. So this a plus b is equal to 8 over 5. That is one of the equations. Now let's differentiate this so that we have dr by dt, and we can use this dr by dt. Okay, so this dr by dt would be minus 2a e raised to power minus 2t plus 2b e raised to power 2t plus 3 over 5 sine t. Okay, now we can put dr by dt as 1 and t as 0 over here. So we have the second relation here, that is 1 is equal to minus 2a plus 2b, and we know that sine 0 is going to be 0. So now solve these equations simultaneously. Um, If I multiply this, let me call this equation number one, this is equation number two. I'm going to multiply the first equation by 2 over here. This is going to be 2a, then I have 2b, and then I have 16 over 5. Okay, so we have a's got cancelled, so I have 4b, that is equal to 21 over 5. So this gives me b equal to 21 over 20. Okay, that is b. And then we have, um, yeah, I can substitute this b into like this first equation. So I have um, a plus 21 over 20, that is equal to 8 over 5. I should change the color. Okay, so this a is going to be 8 over 5 minus 21 over 20. So that is going to be 20. This is 32 minus 21. That is 11 over 20. Okay. Now the equation is going to be R is equal to the particular solution of this equation is R is equal to 11 over 20 e raised to power minus 2t, and then plus 21 over 20 e raised to power 2t, and then you have minus 3 over 5 cos t. Okay, the answer at the back is not correct because you can check your answers being correct or incorrect by just put these values here over here, and that there should be consistency in it. If you put r equal to 1, look at this. If I put r equal to 1, okay, and t equal to 0, so I have 11 over 20 plus 21 over 20, and then minus 3 over 5. I can take this 3 over 5 to the other side, so I have 8 over 5, that is going to be 32 over 20. So you see that um, 4 eights are and 4 fives are. So this is an identity over here. This shows a consistency. So this is the right answer, bacho. The answer at the back is really weird. Okay? So at this, our session ends, and you can try the remaining questions, and then we can discuss them. Okay, so just remember the rule here that your general solution is going to be the complementary function plus the particular integral. Okay, you keep on having the same auxiliary equation for this, and then you have to be careful while substituting or assuming this particular integral. Here guys, क्यों बच्चों?
Yes, sir.
Hmm.